Recording in progress.
Hi students, in this lecture we are going to learn potential energy. Let us see what is it. The change in potential energy of a system is equal to the negative of work done by internal conservative forces. Now see the meaning of this in detail. So we are saying here the definition part. Change in potential energy of a system is equal to negative of work done by internal conservative forces. Right? This is what we are saying. First, let us focus the sentence clearly. Work done by internal conservative forces. So when we want to say force is conservative force is internal or external force. So first we have to define what is a system. Okay. If you know system, forces which are within the system are called internal forces. Forces which are outside the system are external forces. So first we should know here what is a system. Okay. So the change in potential energy of a system is equal to negative of work done by internal conservative forces. So we have learned what is a conservative force in the last lecture. And while discussing that, we have learned one important point, that is work done by conservative force is a path independent. So we are going to use now this point to define potential energy, right? Now see carefully. Let us take, we are moving a block from ground to a certain height, that is h. Okay. We are taking here this block and earth as a system. I am repeating. We are taking the block and earth as a system. Then force by earth on the particle becomes internal force, which is also conservative force. Okay. Now here, for this separation, if you see height is h, means when we are taking from ground to height h, by gravity work is done. Okay. Now delta U equal to negative of work done by internal conservative forces. Let us say initially height equal to h1 and finally height equal to, this is h1, this is h2. Okay. So here when we are saying definition part, we are saying change in potential energy. So first we have to focus when potential energy changes. The potential energy of a system changes if configuration changes. So here question comes, what is the meaning of a configuration? So when we are taking earth particle system, height refers to configuration. If a height is changing, then we say configuration has changed. I am repeating. In this case, if a height changes, then configuration changes. Therefore, potential energy of the system changes, and that change is given by this one, right? Now write down here delta U. Delta U means U or U value when height h2 minus U value when height h1 is equal to negative of work done. While moving it upwards by gravity, work done is negative. Okay, so it is minus mg h2 minus h1, h2 minus h1. Okay, So minus minus gets cancelled. Let us take here, if you observe carefully, H1, H2, both values are known. Mg is also known. Therefore, now this value Mg H2 minus H1, this value is known. But coming to left side, we are having two unknowns. One is U of H2, other one U of H1. We have two unknowns. And here we are knowing difference of these two. Means U of H2 minus U of H1 value is known. This value is known. So if you want to know one of these two values, we have to fix other value. I am repeating. We know U of H2 minus U of H1. This value is fixed. Suppose this value is 1. If this is 1, we can take any value for these two. For example, this is a 2, then this must be 1. If this is a 3, this must be 2. Like this, we can take infinitely many values for U of H1 and U of H2. Okay. So if we fix one of these values, we can get other value. That means we should take one reference value. Okay. So here what I am saying is, suppose potential energy of the system is equal to 0 when H equal to 0. Okay. And let us take H1 equal to 0, H2 equal to H. Okay. According to this, H1 0. So this is now potential energy 0 because we have taken potential energy 0 when H equal to 0. According to this, see what we get. U of H is equal to mgh. Okay. Remember here what is H. So we have taken one reference level. Okay. For example, if we consider ground as reference level, H becomes a height. Okay. If we consider ground as reference level, height becomes H. Suppose I am taking this as, let us take different color to make it clear. Suppose I am taking this as now reference level. So we measure now height from reference level. Okay. So height above reference level is positive. Height below reference level negative. At reference level it is 0. Okay. So when we are taking ground as reference level, potential energy will be, potential energy for a system of earth and block will be mgh. If you take ground as a reference level. Okay. Suppose I am taking now this height as reference level. Then potential energy will be 0 because h equal to 0. We are taking now this height only as reference level. Okay. For example, we are taking now above this level as reference level, somewhere here. Somewhere here, taking this as now reference level. Now it is below that reference level. Then H is negative. H negative means potential energy is negative. Okay. So for same height means for same configuration, potential energy of the system may be positive, may be negative, may be 0. It depends on reference level what we are choosing, which is a completely our choice. Because while solving problems, we are showing more interest in what is a change in potential energy. It is not about absolute value. That's why we can choose any reference level according to our convenience. Okay, right. So this is now potential energy for Earth particle system, where h is a height from reference level. and that reference level is completely our choice. Okay, right. Let us now focus on spring block system. Okay, for this system, what is potential edge? Let us consider a block of mass m is connected to a spring and take a surface smooth and horizontal. Initially, spring was in its natural state. Okay, means no compression, no elongation. Suppose block is given some velocity, right side. Then block starts moving. Then what happens is spring will elongate. So block keep on moves like this. So we want to focus what is now potential energy of the spring block system. We are taking spring and block as a system. Then spring force becomes internal force, right? Again from definition part, delta U equal to negative of work done by internal conservative forces. So here spring force is internal force which is conservative force. Okay. Let us now calculate work done by spring force. Assume initially no compression, no elongation. Now spring is elongating. Then see work done by spring force is equal to, when block moves right side, spring force will be left side. Integral spring force kx, displacement dx, angle between those two 180, cos 180, right? Or let us take initially elongation x1, finally elongation x2. Okay, then see what we get. Cos 180, we can take minus outside. Integral kx dx, that is equal to minus half kx square. Now take limits in that. Minus half k x2 square minus x1 square. Okay, that is now work done by spring force, right? I will arrange this one to, right. So now we want to calculate potential energy. We got work done by spring force. Right. Now delta U value means U of x2 minus U of x1 is equal to negative of work done by internal conservative forces. Negative of that. It becomes half k x2 square minus x1 square. Okay. Again here the logic is, we know k value x1, x2. That means the value on the right side is known. Okay, that means u of x2 minus u of x1 is known. But these two values are not known. So if you want one of these two values, we have to fix other value. Okay, so let us take assumption u of x, when x equal to 0, potential energy is 0. Okay, so this is a completely our choice. Okay, it is completely our choice. Then see what we get. Let us consider x1 equal to 0, x2 equal to x. Then u of x minus u of x1, right? That is 0. U of 0, that is 0. That is equal to half k x square. That means spring potential energy when x is either elongation or compression. Okay, then spring block system potential energy is half k x square. Okay, right. Like this we can get potential energy of a system. So we have seen here for spring block system half k x square and for earth block system mgh. And whenever we are using these two results, we have to keep in mind the assumptions what we have taken, right? Okay. So this is now the definition given. The change in potential energy of a system is equal to negative of work done by internal conservative forces. And we told that when configuration changes, potential energy changing. In case of a spring block system, if a spring is a compressed or spring is elongated, then we say configuration of the system has changed. Okay, right. So the points what we have discussed, U equal to mgh, where h is the distance of block from reference level. Okay, so this need not be ground. This need not be ground. So h is height above reference level. U is positive. So h is above reference level, then U is positive. Below reference level, negative. 0 at reference level. And that reference level is a completely our choice. That reference level is completely our choice. Next, spring block system. It is a half k x square, where x is a compression or elongation of the spring. And here assumption we have taken potential energy of the system is 0 when spring is in its natural state. Okay. So these assumptions we have to remember while solving problems, right? And see next one, law of conservation of mechanical energy. So let us see what is it. So this we are going to get from work energy theorem. See work energy theorem what we have learned. Work done by all forces means net work is equal to delta Q. This is now statement of work energy theorem, right? So here all forces, we can classify these forces into two groups, like internal forces and external forces. Okay, that means first we have to define what is a system. Then we can decide which force is internal, which force is external force, right? So this I'm writing as work done by external forces plus work done by internal forces, that totally equal to delta. Okay. Now let us take one assumption. All internal forces are conservative. What I'm taking, all internal forces are conservative. If you take that, then this becomes minus delta U, right? Therefore, work done by external forces is equal to delta K plus delta U, because we have taken all internal forces are conservative. Therefore, work done by internal forces is equal to negative of change in potential energy of the system, right? And we are knowing that mechanical energy means sum of potential and kinetic. I am repeating, mechanical energy means it is potential energy as well as kinetic energy. So here change in kinetic energy, this is change in potential energy. Now, if work done by if work done by external forces equal to zero, then what happens? Then delta K plus delta U equal to zero. See what it means. Delta K means final kinetic energy minus initial kinetic energy plus final potential energy minus initial potential energy equal to zero. That means final kinetic energy plus final potential energy is equal to initial kinetic energy plus initial potential energy. That means there is no change in mechanical energy of the system. And when we can say this, one condition, by external forces, no work is done. Second condition, all internal forces are conservative. Then we can say mechanical energy of the system is a constant. Okay. Let us see now notes for this. This is what we have taken: external forces, internal forces, delta K. All internal forces are conservative. Then minus delta U. It becomes now delta U plus delta K. So if all internal forces are conservative and no work is done by external forces, then mechanical energy of the system is a constant. This is known as law of conservation of mechanical energy. Okay. So the next lecture we can discuss questions basing on this conservation of mechanical energy.